This is the lecture for 10.5, the Synapse. In this short lecture, we're going to talk about a presynaptic neuron and a postsynaptic neuron or cell. So basically what's going on is we're going to generate an electrical signal or a nerve impulse. That's going to come down a neuron. We're going to change that into a chemical signal, which gets dumped into a synaptic gap or cleft, diffuses across, and either excites a new neuron or causes some sort of excitation in a cell, like a muscle cell or an adrenal cell. And so that's called a synaptic transmission, when we have a change in communication from one neuron to something else. And so a synapse is an area. It's a junction or meeting site between a neuron and another neuron, two neurons. So from the axon of one neuron and the dendrite of another neuron. So the neuron before the synapse is called the presynaptic neuron, and the neuron receiving the information, the second neuron, is called the postsynaptic neuron, referring to that situation. We'll have a diagram here in a little bit. Special note, those neurons don't touch. There's a gap, and that gap is called the synaptic cleft or synaptic gap. Sometimes that secondary structure might be a muscle or some other cell from some other gland. So here you can see a situation where we have maybe a multipolar neuron up here with its, whoops, I'm just trying to create some branches coming off, and here's the axon coming down with the electrical signal moving in this particular direction. Okay, so we're looking at this area right here, and we're kind of zooming it in, looking real close. So here's the presynaptic neuron right here. This is the presynaptic neuron carrying an electrical signal down. Once that electrical signal comes down, we talked about earlier this year in the muscle unit, calcium is going to come rushing in, and those synaptic vesicles are going to fuse with the edge of that cell membrane, dumping its neurotransmitter, whatever it may be, in that cleft, and those neurotransmitters are then going to attach to receptors on the postsynaptic neuron, and that's what this one is here. This is the postsynaptic neuron, the one on the other side of that. So then this neuron will receive that signal, and then this is going to generate a new electrical impulse, and that's going to be carried on. So as we take a look at this, maybe just a little bit closer, so we're zooming in. Again, you can see the presynaptic neuron. The electrical signal is coming down. Calcium is rushing into the neuron, causing these vesicles. Here's a vesicle right here filled with a neurotransmitter. We talked about acetylcholine earlier this year. Could be other neurotransmitters. That calcium that comes in causes those synaptic vesicles to fuse with the cell membrane of the presynaptic neuron, dump that neurotransmitter into this synaptic cleft or gap, and then that neurotransmitter diffuses from an area of high concentration to low concentration, touching a receptor, and then generating a new electrical nerve impulse, carrying that electrical impulse onto either a nerve or a muscle, so we can have a muscle contraction, or some other gland or cell. So here's an actual picture of a microscopic view of what this looks like. And so you can't totally see everything, but here is our presynaptic neuron is up here. Here you can see a mitochondria in the cell here that's going to make ATP, and all these little tiny bubbles in this area, those are the synaptic vesicles that house the neurotransmitter. And then, so when the electrical signal comes down the cell, calcium is going to rush in to the cell. Those synaptic vesicles fuse with the cell membrane, like down on this end down here. And again, that neurotransmitter diffuses across this little tiny gap that is fractions of a millimeter long, and then our postsynaptic cell and membrane receives that information, and we generate a new electrical impulse. Most of that should be pretty much a review for us from things that we talked about earlier this year.